Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. My topic for tonight will be a long video format topic, and this will be regarding the so-called study of natural and common logarithms. Okay, it will be the concept on how to solve a problem by using natural and common logarithms. Okay, let's proceed. To illustrate the concept of natural and common logarithms and solving a problem, we are given the equation 2 raised to 3 plus x, and this should be equal to 5. Okay, that is equal to 5. And the problem is asking for the value of x. If you do not know natural and common logarithms, this will be a hard problem. Or if you are not familiar with the so-called laws of exponents, you cannot solve this problem. But the easiest way to solve this problem is actually by using I will present solution number 1. This will be solution number 1. Okay, that is by using natural logarithm. Okay, we will be using natural logarithm. So, if I will try to bring out the solution, it will be something like this. We rewrite the given equation 2 raised to 3 plus x, and this should be equal to 5. Okay? By presenting the natural logarithm solution, okay, I will try to take the natural logarithm of both sides. Okay, if I will try to take the natural logarithm of this one, it will become 3 plus x times the natural logarithm of 2. And this should be equal to the natural logarithm of 5. Okay? Natural logarithm is actually designated by the letter ln. Like what I said, if we try to take the natural logarithm of the left-hand side, okay, we should take also the natural logarithm of the right-hand side. And if we try to simplify this one, if we try to take the natural logarithm of this one, the exponent should go down, then we'll take the natural logarithm of the base. So the exponent goes down times the natural logarithm of the base, and this should be equal to, for the right hand side, it will just be simply the natural logarithm of 5. So in here, the only unknown now is the value of x. So if we try to simplify this one, it will become 3 plus x equal to the natural logarithm of 5 over the natural logarithm of 2. Okay? In the calculation of this natural logarithm of 5, we cannot do anything about it, but we must have to use our calculator. It's a scientific calculator. And if we try to simplify this one, x now should be equal to, if we try to take the natural logarithm of 5 by using the calculator, we'll just display 5 here, then we'll increase the natural logarithm, and that is actually 1.609. Okay? And for the natural logarithm of 2, just display 2 here, and press the natural logarithm. This is all over 0.691. Okay. This is minus 3. Okay. This is x. We transpose this to the right, so it now becomes negative. And if we try to take the ratio of this one, 1.609 divided by 0.691 equals, this is 2.32. 2.32. 2.328. Okay. This is almost twice, right? So 2.328 minus 3. And the value of x now, the value of x, so this is minus 3 equals, this is minus 0.67. So the value of x here should be negative 0.67. And actually we could check that one. If we try to check it, okay, we will compute 3 plus x. So this will be 3 minus 0.67, and x now will be equal to 3 minus 0.67, that will be 2.33. So the value 3 plus x on the given equation will be 2.33. So we will try to place the value 2. 3 plus x is actually 2.33. And will it be equal to 5? Okay? We are checking the validity of our answer. To compute for this one, you cannot do the long computation of this one, but we must have to use our calculator. So we'll just display 2.33. Oh, no. We display the base 2. Okay? Then we raise that to 2.33. So we'll use the equation here, y to the x, 2.33. And will it be equal to 5? Okay? This is almost 5. 5.02, and this is approximately equal to 5. So this is approximately equal to 5. So the value x equal to negative 0.67 is actually correct. Okay? Because according to our checking, if we raise the value 2 raised to the value 3 plus x, 2.33, what will come out is 5.02 is almost equivalent to 5. That's the first solution. That is by using the natural logarithm. Solution number 2. Solution number 2. Okay, I will try to check my camera if it still works fine. It works fine. For solution number 2, we will rewrite the given equation 2 raised to 3 plus x, and this should be equal to 5. By using the so-called common logarithm, if the base of the logarithm is 10, or just simply log, that will be common logarithm. So it will become 3 plus x times the common logarithm of 2 should be equal to the common logarithm of 5. Okay? This is simply log without any base that is understood to be common logarithm. Under natural logarithm, the designation of natural logarithm is just simply ln. Natural logarithm ln. So for natural logarithm, that's ln. And for common logarithm, it will just be simply log. Okay, so at least you know what will be the difference of these two here. Again, if we try to simplify this one, 3 plus x equal to the common logarithm of 5 all over the common logarithm 2. Okay, and x now will be equal to, again, we will be using our calculator here in the computation or in taking the value of the common logarithm of 5 and common logarithm of 2. So we'll just display 5 here and we'll press the simply log on the calculator, scientific calculator, log. And the common logarithm of 5 is actually 0.699. This is 0.699. And the common logarithm of 2 will just display 2 here. Then we'll press the common logarithm. And that will be 0.301. Okay, minus 3. We are solving for x. We transpose this 3 here to the right, so this is now negative. So x now will be equal to 0.699 divided by 0.301. 0.699 divided by 0.301. Oh, that will be 2.322. 2.322 minus 3. And if we try to compute for the approximate value of x, this is minus 3 equals, this is 0.67, negative 0.67. So the value of x by presenting solution number 2, which is by using the common logarithm, the value of x is actually negative 0.67. From the first solution, by using the so-called natural logarithm, the value of x is still negative 0.67. And again, as a check to the validity of our answer, we check it. Okay, x is negative 0.67, like what I said. If we try to take the sum of 3 plus x, that will be 2.33. And if we try to raise the base, which is 2, raised to 2.33, the question is, will it be equal to 5? And the value is just a little discrepancy that is simply on the accuracy of the calculator, plus the so-called truncating of the significant numbers. That's where the 0.02 came out. But 2 raised to 2.33 is actually approximately 5.02. And this is approximately equal to 5. So this is true. It is correct. Okay guys, that's the so-called concept of natural and common logarithms and the so-called solution of a problem. If we are given a problem something like 2 raised to 3 plus x, and this should be equal to 5, and the problem is asking for the value of x. So if the unknown is on the exponent, okay, it's a must that we should use either natural logarithm and common logarithm in the so-called solution of it. The other solution of this one is actually by using the so-called laws of exponent, but I don't think that the laws of exponent will be applied here not so easily, because the value of x is actually not exact. It is a decimal number. It is negative 0.67. The laws of exponent will only be good for this problem here if what comes out and the value of x will be exact. But since the value of x is not exact, okay, the proper solution is actually by using natural and common logarithms And of course, our knowledge on the so-called punching of the values of the logarithms on the calculator. So we should know what's the meaning of ln on the scientific calculator, that's natural logarithm. And also on the scientific calculator, log is just the so-called common logarithm. Okay, that's it guys. So that's it for tonight. Good evening from Los Angeles. Professor David J.